Hello, everybody. Welcome to an episode of Ventures with David, a space where you and I learned about new tools, interesting frameworks on how we can deliver good value to our users, connect with others, and finally learn about managing teams. In today's conversation, I had the chance to talk to Jason Mays. He's Google's Web AI lead. And I want to talk about Web AI for one side, but also I want you to introduce you to Jason as a way to learn how product manager works. In the first part, talking about Web AI, this is an interesting tool because you are removing barriers for customers to access your solution because Web AI precisely is about putting the solution in the client side instead of the server side. So, in other words, you are, instead of deploying your model in a cloud side server, you are allowing the user to access the model directly on the browser, which is great because it allows the user to test your product and then provide feedback fast enough for you to improve and iterate. On the second part, which is a little bit more implicit in the conversation, and you can also check Jason's profile and his talks about Web AI, is more about observing, learning how to be a product manager, right? Product management is about representing the customer in front of engineers, data scientists. But you cannot represent your customer, your user, if you don't have sufficient space of interaction with the user. If you don't create this excitement around your tool, and if you don't listen and improve your tool obsessively to a point where people start downloading the tool. With that goal in mind, Jason has an interesting experience that we all can learn from. How to create those communities, how to create that excitement. So I hope in this conversation you learn two things. One, you can be super scrappy, you can iterate faster by deploying your AI ML tool on the browser directly. Two, you can learn a little bit about the essence of product management, specifically for solutions that are technical, how you can create communities to iterate, test, and then continuously integrate improvements into your AI solution. And I hope you learn as I did. See you around. Welcome, Jason. How are you doing?
I'm very well. Thanks for having me on your show. Great to be here today. Happy to answer any questions. And of course, at that summit, we had 150 people. That's all I was allowed to have in the room due to capacity reasons. But there are many more people using it today, as we can discuss later on. So, but yeah, ask any questions you have.
Thank you so much. I plus start asking about your background and your trajectory and how you became the visible face and also the creator of this vibrant community around Web AI.
Yeah. So I've actually been at Google 13 and a bit years now, so quite some time. And essentially, I started out as a web engineer, full stack situation, bit of back end, bit of front end, UX design, all that kind of stuff. Around 2015, I was working as a creative engineer, which is basically investigating emerging technologies and trying to use them to tell the stories of our largest customers globally, creating world firsts, combining technologies together, essentially. A really fun role. And it was at that time that I was attempting to use machine learning to recognize soda cans for one of our clients. And regular computer vision from computer science just wasn't cutting it. So I decided to investigate this thing called TensorFlow at the time, which was internal only, wasn't launched at that time, to see if I could repurpose their image classification model to do that task. And sure enough, it was able to classify the cans that I needed to classify. Now, I figured out that this was really hard to do at the time, even though I had a master's in computer science. I was like, this is far too hard to retrain. So I took it upon myself to make a cloud-based system whereby anyone could upload an MP4 video to my system of some object. And then 20 minutes later, you get a JavaScript API where you can send me an image and I'll tell you if the object's in the image or not. That turned into Cloud Auto ML Vision. And that was the start of my journey into machine learning, basically. So that's when I started flipping over to representing TensorFlow.js, which was essentially the first form of web AI. And that was combining my skills as a web engineer with my passion for machine learning at the time, essentially. So yeah, it's just escalated from there. So, yeah.
That's amazing. And I'm curious to know how, as a creative engineer, do you prioritize what things to try? I mean, what things worth to explore further, right? Imagine your schedule and you try different emerging technologies,
Mhm.
but how you prioritize what is relevant?
So the first thing we do is we come up with ideas. And we had a team of people. We had a strategist, we had a creative director, and creative technologist or creative engineer at Google. And that's our like pack of people that works on any one given project. So we'd work together to come up with ideas that we think are relevant to the client's product that they're trying to launch or whatever it is they're doing. That could vibe well with the target community they're trying to actually reach. And once we had those ideas, I then had to think about how I could make them because, again, these ideas typically had never been made before. It was a world first. That was the criteria for the projects we were working on.
Mhm.
And there's no Stack Overflow you can go to just to grab the code because it doesn't exist yet. Essentially, it was up to me to break that down into what do we need to make that happen? And if something doesn't exist, what would that be called or what is it that we need to make it happen? And so on and so forth. So it's a classic computer science problem. You got some larger problem that you break down to smaller components and then you have at it at each little one until all the bits fit together and do the thing you want to do. So let's take a hoverboard, for example. We want to make a hoverboard. Obviously, we can't make a real life Back to the Future hoverboard necessarily for going anywhere. But if you constrain the problem and say in a private venue, you could have magnetism powering that within a certain space, just like the maglev trains work. So you could make a hoverboard that worked in a constrained space for a prototype for a customer if you wanted to. So thinking outside the box like that, we're going to say no, but rather than just no. So yeah, figure out. Yeah.
I see. Yeah, having that mindset of adapting to what the customer demands, but also not being constrained by the current restrictions is something that I have seen in Google's products in general. But in Web AI, and then after we explore more about your background, what has caught my attention is its power and its portability, right? In places where you have, you get good internet connection,
Yeah, exactly.
Web AI is it's a perfect tool. I wanted to ask about if you could tell us a time where you had to identify a specific customer need.
Hmm.
And you were able to successfully tell engineers, because I guess that's part of your role, you were able to say to the engineers, hey, we need to do this, and then translate the customer need into the engineering language. How is that process? I imagine you're doing that constantly, representing the customer and then translate that to engineering.
It's more the other way around, actually. It's typically, I did created all the prototypes myself entirely without an extended team. We're a very scrappy team, and sometimes I'd reach out to other engineers, say the TensorFlow team at the time, which was new, to understand some new knowledge that I didn't have to learn. But I would then assimilate that knowledge and then do everything myself. I have led teams in the past as well on certain projects, but generally speaking, in that role that we're talking about, it was a lone wolf with other collaborations kind of role versus leading a whole org or something in that situation to deliver some product in that case. Yeah. But I have worked on products, and in those situations, of course, it's a very typical um, flow for project management, that kind of thing that you do for any engineering deliverable. But for the projects I was working on as a creative engineer, it was more I'm in charge of my own destiny there, and if I say I can do something, I have to damn do it. Otherwise, I failed, and no one will trust me again. So estimating these things was the biggest challenge because um, how do you estimate something that's never been made? How do you have the confidence to say that yes, we can actually do it, and that kind of stuff? That's the bigger problem I had in that role. So, and giving timelines. A lot of these prototypes I would make within 1 or 2 weeks, when other industries said it was impossible, and they'd spent months trying to solve the problem. Yeah, it's a different time scale we had to work in. Yeah.
That's amazing. I guess you put yourselves in a fascinating role at the moment of trying prototypes. And then you go to the engineers and say, this experience a customer, how we might have this experience. Is that correct?
But yeah, put yourself in the mind of the customer because at the end of the day, we've got to pitch to the CTOs and directors and VPs of these companies. And we worked with Google's largest customers. So these are big name brands that you'll know. And these people, they're not technical necessarily. They need to be
Right.
explained what you're making in a way that sells the vision to them. So you got to be able to talk in the other language of whoever you're talking to, be that engineers or be that a director of a company who wants the TLDR and why it's a win for their company and all that kind of stuff, and what's the costs and how long is it going to take and all that kind of things. Depending on who you're speaking to, you've got to deliver it in the right way and you've got to adapt to the audience that you're talking with at any given time. Yeah.
That makes total sense. And this is the perfect connection for us to talk about web AI.
Yeah.
And that's the jewel of the crown for you. And I want to ask you the basic question.
Yeah.
I know there's plenty of information about it out there, but nothing like ask the creator about it. Like, what is web AI in? How does it differ from traditional server side applications?
Sure. So first of all, I wouldn't say I'm the creator, but I'm probably one of the most known web AI guys out there because I basically grew the community from almost zero to almost a billion downloads today. So that's really cool. But the creators were a research team over in Boston at Google, actually, who made the TensorFlow.js and DeepLearn.js libraries back in the day. Now, essentially, web AI is the art of taking a machine learning model and running it client side in a web browser instead of on the server. And the reason you want to do that is there's a few benefits you just can't get with cloud. First is privacy. When you're talking to a large language model or something like this, all that text that the user's writing stays on their local machine, or if it's an image, the image stays on their machine. It's not going to the cloud for inference. The second one is cost. As Gen AI today costs companies a lot of money, and we're seeing a whole bunch of startups, mid-sized companies, even large companies start to use web AI because it saves them significant costs. If you take the meeting we're in today, for example, let's say our meeting's going to be 30 minutes long, 30 frames per second, and you're doing background blurring on the server side, assuming a really low cost of 0.0001 cents per segmentation. For a million meetings a day, that's 56 billion segmentations every single day, which is around 2 billion in costs per year
That's
for that
crazy.
service. It saves a lot of money. And then, of course, the other benefit, of course, is you can have real-time applications, which you can do on the cloud as well, but it very much depends on your latency and mobile network connection. If you're in the middle of a field, you can even go offline and it still works, which you can't do with cloud and all that kind of stuff. So there's a whole bunch of benefits that we get with the web AI ecosystem. And that's why we're starting to see a lot of Python developers actually port their models to web AI so that developers can use them in these cases. And not to mention, if you're a researcher at Stanford or something like this, you can get more eyes on your new model because instead of 10 people building that backend that you've created with all the dependencies and setup environment with the CUDA and all the GPUs you need, you can just publish it to a URL that anyone can just click on and it works right away. We've had people run like 70 billion parameter models in the browser, 7-0. Obviously, the average person's not going to do that. You need like 64 gigs of RAM if it's all quantized and stuff. But it's possible, right? And the download time is the same as you would need to do on the server anyway to download the model files. You're still going to download the model file somewhere. It's that you're doing it on your client machine instead of the server. And then you don't have to have all this setup for the Linux environment, whatever it is, the CUDA environment, or that kind of thing. And we can run on non-CUDA things. We can run on Intel, on ARM. It doesn't matter. If it's a browser, we run in it. Yeah, pretty cool.
That's the number you provided me on the potential costs for using web AI application sounds like an amazing promise. And I'm curious, given that web AI is a more rational way of using resources in terms of cost, but also the CO2 emissions, what do you think the industry is not, for example, creating more apps on the website?
I think the companies that can use the smaller models are starting to port things to on device. But
Okay.
of course, the latest research is not going to fit on a single GPU. So in that case, you are going to use a cloud system with a whole GPU cluster to run that one
Right.
model. So I'm not saying we're going to replace that anytime soon on the client side, but for these smaller models, especially in like up to maybe 9 billion parameters size. These are very capable to be downloaded in a reasonable time frame and then cached so you don't have to download it again in the future. And those run very well on a single GPU. And I think
Right.
those are the ones that we're starting to see have real benefit. And you may have seen a demo I
Yes.
launched last week where I showed the world for the first time ever web AI agents running locally in the browser essentially to
I
do
saw the
agent
demo, by the way.
behaviors. Yeah. Mm. Um,
Really cool. The fact that you can communicate, for example, with with Google Flights and save the parameters of your flight.
Yeah.
It simplifies so much. And then you can also provide utterances to modify the flight you want, the time, and that was amazing.
And that
That's
2 billion
great.
parameter model has the same performance as our 7 billion the year before. That's the way things are going. Smaller models are getting very capable. And sure, if you're a researcher, the latest and greatest will be on the cloud. But do you actually need that to make what you're making? That is
Exactly.
the question. Yeah.
That's what I was wondering if you need a mundane task of less parameters, and or you can, if you want to provide like a prototype, you don't necessarily need a server. So I was wondering why there is so much passiveness on not providing these type of tools to the customers to rationalize costs. That's something I still quite don't understand. Tell us a little bit more about TensorFlow.js, right?
Yes.
We here in Stanford, like the king of programming of code is called Python.
Yeah.
And when I talk about JavaScript, I see all faces.
Yeah.
So
I've been down that path before. Yes.
why TensorFlow.js is super interesting and
Yeah.
what we should learn.
So, first of all, I'd like to say that academia is a bubble of researchers who use Python
Yes.
because there's loads of cool maths libraries in it. That's basically the reason it was born in Python, all this AI stuff. We had all these amazing maths, low level things that you could leverage for academia to get the job done of implementing these machine learning libraries. And, fair play. However, now that we're starting to get these libraries ported to the JS community, and let's also bear in mind that roughly 70% of professional developers use JavaScript in production outside of academia, then there's a big reason to at least appreciate and understand the JavaScript ecosystem. Because if you're launching anything, there's a good chance the company that ends up using your thing that might be in Python today needs to convert it to run in that ecosystem tomorrow. And a great case study of this is LinkedIn. In fact, when you go to a LinkedIn site, it uses a TensorFlow.js model to deliver the web page to optimize the imagery in real time. And they're running that in Node.js on the server side. So remember, Web AI is intended for the client side, but Node can run on the server. So JavaScript. And the reason they use that is because it's faster than Python. The just in time compiler of JavaScript is very advanced these days. And if you compare Node.js, TensorFlow.js implementation versus a Python implementation for the same model, of course, the model inference will be exactly the same because Python and Node are essentially wrappers around the TensorFlow C++ library that is written in. But the pre and post processing that you have to do is written in your language of choice, Python or Node in this case. And Node benefits from the just in time compilation from the V8 engine and all that kind of stuff. And that allows them to go 15, 20% faster. And at LinkedIn scale, that's millions of dollars saved per month. so, so basically, Python is not as great as you think in terms of efficiency and power usage and all that kind of stuff. With other languages, not just JavaScript, others included too, are much
Mhm.
more efficient. It's a starting point, and a lot of the ecosystem is in Python, but you shouldn't limit yourself to thinking only in that, is my thoughts on the subject. So I think together we can be better together essentially. So I'm not saying don't use Python. Of course, all the stuff is there already. Don't reinvent the wheel, but consider at least porting the model that you've made to be in a web AI form so people can use it in the ecosystem of their choice, right? So do the training in Python, but then convert the final model to a variety of forms so it can run on mobile, web, and other ecosystems. Yeah.
I'm drinking the Kool-Aid and I already started your course, Flow.js, and I want to post you created a whole series of courses, and there is a bunch of interesting things to watch out there to learn this interesting language. And I totally agree. If this is the direction of where we're going to increase more portability, but also super cool when you can produce something and then put a demo that is easy to access for everyone.
Yeah.
It allows you to have more visibility. I agree with you. Um, in the case of agentic development, we are now in the hype of agents and LMs.
Yeah.
Is there
Yeah.
a particular reason why Web AI is compelling to develop products and agents?
It's the same reasons as I mentioned before. Our benefits on the client side are the main reasons you want to use web AI in that case as well. Mostly the cost reason, probably, if you're going to be running these things 24/7, chatting to them all day long, doing various tasks. You can probably save a significant inference cost by just getting the client to do it on their own machine.
Mhm.
So I think that's the main thing right now for us. I'm very excited about how this can apply to browsers, especially though, because if you think about it, the web ecosystem is the only place really where you work across domains, literally. You're signed into Photoshop.com and also Google Drive at the same time. So that's the only place where you can write an agent, maybe in a Chrome extension, which could be something like, hey, crop this image for me and insert it into a Google Doc. And you can do it without having to do anything else. You got all the cookies signed in already. You can then just make the calls and get the responses, and the agent can do all that work for you. You can't do that on any other platform, really, because on your server, you're not signed into all those things. You could be, but you're not. So, and it's
Right,
again,
right.
the browser's a very natural place to consolidate all this knowledge of the world and get an agent to use it, essentially. So my vision for the future is as you browse online, your browser becomes smarter about the capabilities it can perform because maybe these websites expose, like, I call it like an AI.json file. That format's still being explored what that should be. So, but take it with a pinch of salt. But imagine just like you got like a robots.txt file in the root of your domain these days to say what not to crawl for all the search index
Mhm.
engines. You've got an AI.json or equivalent file that explains all the functions you can call by an agent, and it describes them in an AI agent friendly way. At that point, as you browse the internet, you get more capabilities for the things that matter to you. So if you're an artist, you're going to have lots of arty websites for maybe getting stock images or maybe cropping and doing image manipulations or whatever it might be. So you'll have functions that can do those kinds of things. So when you ask it a question like, oh, I need to like crop this, change the brightness and blah, 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 it can actually figure out how to do that for you instantly.
That, yeah, I never consider the fact that you can, for you, it's probably obvious, but you can make your browser smarter.
Yeah,
And I agree. The agents have the integration browser agent is very natural. And in fact, we want, when we code agents, we have to tell the agent explicitly, go to the internet or describe information in the browser. It happens there.
exactly. And this is what I predicted at the Web AI Summit last year. I said that 2025 is going to be a year of agents. And what does this mean for the internet and when you browse websites? And I made that prediction back in September last year that this is going to happen. That's why I made my demo this year of an AI agent working in the client side, just to prove we are heading in that direction and it's possible.
Very
And
smart.
we're now there, basically. If someone wants to go and have this cross domain common knowledge, then we can actually do these kinds of things. Yeah.
My final question for you, Jason, this has been very insightful. What suggestions would you give to junior web developers, AI developers, what they should pay attention in addition to learn web AI? And
Solve
what skills they
problems
should
that
develop?
matter, I think is my thing. I think a lot of people focus on research in academia, and that's great. But at this point, I don't care if the model runs 2% faster. I want to see things that I can use to solve problems in my actual daily life. Maybe it's a new model architecture, a new model type, fair play. But go beyond just making the model, actually make demos that are useful to people that use the model that you've created as well. So instead of just showing it with some dummy input in, dummy input out, that's great, but apply it to something real, solve a problem. Why is that model even needed? I want to see more examples like that. I don't know. Maybe it's a medical application. Maybe it's something for, solving some problem that existed there. Apply it to that in your research. So for your research paper, don't just make the research paper, but make the business application or the problem that it solves application as well. I know it's a bit extra work, but I find that sometimes the people who make the models are some of the best people who can apply it to different situations. And that can be the inspiration that an industry needs to get going. And then you become even more popular because other people in the industry realize the applications of the model versus someone like me having to tell them, oh, you can use this fancy research module that's very abstract and sitting on a shelf gathering dust. And if you apply it like this, it can be used in a whole different way. And they just don't realize that.
That makes total sense. Being intentional with the problem you want to solve and then what it matters. And I think sometimes when we're in academia, we focus only in the model per se, and that's so pernicious for society in general. People are not focused on solving problems.
Yeah.
I wanted to thank you so much for this insightful conversation. And hopefully I can have you here to talk more about the next milestones in the exciting trajectory of web AI. Thank you, Jason.
Thank you very much. See you soon.